So what is XML? Well, XML stands for Extensible Markup Language. But what does this mean? Well, XML is a way of describing an object through its components, or sub-objects in a way. For example, I have this dinner menu. Looking at the menu itself is an object, but what does a menu consist of? Many different food objects. And so I'm able to describe that menu by the food objects it contains. Now looking at food, what does food contain? Well, it has many own parameters of its own, such as name, price, and description. These parameters themselves, though, however, are not sub-objects because I could not reduce the menu further or my data stops at this level of description. So what is the beauty of this? Well, XML allows me to describe a component or object in any way, shape, or form through its properties. This allows it to be easily stored, sent, or distributed, and is self-descriptive so that I am fully understanding of the data itself just through looking at it without specialty knowledge.
So what are the similarities between XML and databases? Well, both XML and databases are ways to represent a user's data, or data in general. There are a few differences, however. As described earlier, as XML consists of components which are made up of subcomponents of more and more detail, it represents data slightly differently than a database or an SQL relational database, where each row describes all its components or properties, columns in this example, on the same level. Though you may say that this differs as we have subtables. For example, in the bike example, we have a subtable for wheels. However, when you are selecting data, you do not go through each of the properties. You in fact perform a join, which then makes all the data the same level of detail essentially. XML differs from this, as you would to select data from an XML, or if we wish to query data, we would then go through each level of detail until we finally get the component we are looking for. This is another similarity of XML, as it provides a way for storage and querying data just like a database. But XML and databases do differ, however, as XML lacks many of the features of a database, even though it stores data, as it is unable to have multi-users, many of the useful features such as multi-querying and indexing, and thus this makes them very different in practice.
So how do we integrate XML and databases? Well, very simply, the main use for a relational SQL database is that we can use XML and a database as a backup. Given how I explained earlier that XML is very useful in representing data, just like an SQL database, we can then use that XML document to do a read or copy of the database and store it in a way that is descriptive and easy to understand. For example, looking at my previous example, we have our SQL database and we've described each table with an XML document itself. This works just because they're both descriptive of data. The other main uses of XML and databases is the data-centric model, and that is the main use, as I talked about earlier, as a backup or storage of a database or a way to transfer data from one database to another. But the other use is the document-centric model. That's where instead of storing the properties of the data, we store a document which then describes the data itself. Due to how an XML document being able to describe unlimited properties that can be organized in any way, this has many applications. And this is generally used in something called NoSQL databases. Thank you very much, and that is how XML and databases integrate and their similarities. Thank you.